And I believe right now we can start with our first presentation. So please welcome on stage Robin Pokorný.
Hi, my name is Robin. I work here at Productboard, and today I want to share an approach that had immense impact on how I design things. And I think it helped me solve some problems. First, I will ask you, who here works in a company that is agile or claims to be agile or work agile? Or works in a team that wants to be agile or claims to be agile? Great, cool. That's what I expected. Like everybody wants to work agile. And then we have software design, we have architecture. And when I first saw that, I was like, how does it work? Because these two things are like the opposites. You will ask somebody, what is agile? What does agile mean? And you go and you read Agile Manifesto. By the way, if you haven't read that, you should. Like it's really short, and I think it's up to the point. And don't confuse agile with agile frameworks or other things. However, agile, I think, is a desirable thing to have. And one of the points says, we value responding to change over following a plan. That's great, cool. We will tackle things as they come. We will not, overthink. And then you say, okay, we have architecture. We need software architecture. What is architecture? And you go and you see that many people claim Martin Fowler said that, but I think that he didn't. However, people agree that architecture is stuff that's hard to change. Right? That clashes. Like, how do you do that? How can you develop in an agile way and have an architecture? So one of the options would be, do I need an architecture? I will just, develop the next iteration. I will see. I will make another one. It doesn't work because you will hit some roadblocks. You will hit problems that are more difficult than your next iteration. And also you will make a lot of decisions, which are architectural decisions at the very first iteration. And this could be very difficult to change. If you, could wish for anything, and you would say, okay, what is the best architecture? You would say the best architecture, because that's the easiest for all of it, no rework, it means you get it right the first time, right? You just get it right. Like somebody comes with a problem, I start a new company, I'm the founding CTO, whatever, I set architecture and it stays for the next 20 years. Yeah, okay, I mean, it already sounds silly, right? Why does it sound silly? Because you can't predict what's happening in many areas. Imagine when Docker came, right? It completely changed the scape. Like it was a huge shift. When I mean Docker, I mean like the containerization, right? When we had virtual machines, again, the same shift. If 20 years ago, you came to somebody and said, I have this idea that would help us develop faster, and I call it microservices, and I need 50 servers, 50 OS licenses, and I need a database server for each of them. The guy who's running the IT would just, stare at you, and then they would probably start screaming because that's just not an option, right? It was not an option 20 years ago. So even if you had that idea, it wasn't feasible. And the learning from that is that you can't predict technological shifts. Another shift that happened was DevOps, right? Again, something huge, and that had a huge impact. If you didn't design for that, you will be screwed. Best architecture would also provide extensibility. You're like, okay, we set up the base architecture so that I can change anything at any time. I will put abstractions, and I will put here, I know that I will switch my persistence, so I will put a layer there. No, you don't. You don't know where the change will come from. And all of those, I'll need it later, accumulates. You would have to create a base layer, which is so abstract that you can't develop anything because you would have to touch so many levels of abstraction and indirections and everything. So it would hinder your ability to even develop. And then also, best architecture would be used everywhere, right? If microservices are the best architecture, it's a solution to most of the problems. But you will soon find out that the architecture is insufficient in one way or the other. Either it doesn't support a use case you really care about, or it's just too big and too expensive to run, and you don't want it. So learning is there's no universal architecture. So now you look at this and you say, okay, what are my options? I can design something, and then I would be miserable. And because it's architecture, and because it takes time to see the problems, in 2 years, I will be miserable. And when I wanted to describe how miserable you would feel, I remembered that there's a really nice musical piece that explains this misery. And that's how an architect who thinks that they can design things from the scratch will feel like, let's say 2 years after that. And I will try. Okay. Let me see if my system doesn't work, but I can do things. And the musical piece is, of course, Bartlett Bride. There's a way how not to do that in 2 years, right? The way is to accept that there are these limitations, that you can't predict the future, that you can't put so many layers of abstractions. And the approach is called evolutionary architecture, as defined in the book by Neil Ford, Rebecca Parson, and Patrick Kua, Building Evolutionary Architecture. There are 2 editions. The pink one is the original one, and the colorful one is the new one. They explain things. And to sum it up, there's a definition. I will read it out, and I will talk about it a little bit more. It says that an evolutionary architecture supports guided, incremental change as a first principle across multiple dimensions, right? We will be talking more about those points, especially the guided. What is important here is multiple dimensions. That's something that I haven't thought before, but it means that you don't build the architecture just for the technological shifts I was talking about. There are also social shifts. And for example, DevOps for me is one of those, where it's not necessarily technological difference, but it's approach difference. And you can have, I don't have a note, so I don't remember the other. Security is another dimension, right? It's also something you need to build into your architecture. So you need to think about all of those, and you need to be able to move your architecture not in one, not in two, but across multiple of them at the same time. Incremental here refers to what I was saying about DevOps. It was enabled by DevOps, meaning I can run certain checks during every build so that I know that what is being deployed is somehow in aligned with what I want. That gets us to the last point, which is guided, right? Why is it called evolutionary? Evolutionary means some small, steps. Some people say it could be called adaptive. There are some problems with that. It could be called agile. People don't like that either. Evolutionary here shows that there is certain level of randomness. However, we don't want it to be like real evolution, so we don't want it to take thousands of years to get things right. We want it to be guided. Guided means that I have some insights about what I want from my architecture, and I will somehow, I will be doing about it, tell how to check that. I know it's fluffy, but we will get to more specific things. Let's first talk about what I can ask from architecture. And there's a useful tool which people call architecture characteristics. And this is a slide created by Mark Richards. However, you can imagine there are I saw a list where there was 100 of these characteristics. Many of these things are possible things you care about. And if you read them, things like performance, responsiveness, elasticity, scalability, in a way, you would say, okay, I want this, this. That's not possible. You cannot achieve all of those. Many of those are in odds with each other. So what you, as an architect, need to do is to understand the business requirements, the reasons, give some insight about what you expect to be the biggest problem. And then you will choose let's say you will choose a performance because your system really needs And that's performance here is defined as amount of time it takes for the system to process a business request, right? And it's different from concurrency, it's different from scalability or elasticity. Another thing you want to have is testability, because what you build is very complex and you need it to be always right. So this is a useful tool to start thinking about what I really want from my service, for my system. I talk about services because one of the great benefits of microservice architecture, you will soon see, is that you can have different characteristics per service. So you have one service that needs to be really performant, and then you have another one which needs to be fault tolerant, for example. And you as an architect define these. When you have these characteristics, it will help you to choose the correct, I'm not sure if architecture is the right word, architecture pattern, right? You all know patterns. And in a way, maybe I'm thinking about that. And it's an analogy I haven't made before. Evolutionary architecture is like taking these characteristics and finding the right patterns and making sure they stick. So how do these patterns look like? This is from the similar worksheet by Mark Richards. And you see, you have several characteristics. You have these, let's say, patterns like layered architecture, microservices, event-driven, space-based. They have different, like they perform differently for each characteristic, and that's important. So when I highlight what I want to work on, let's start with performance, right? And I see if I really care about performance, well, it's easy. I need to select event-driven or space-based because they will provide the best performance. However, that's not the only characteristic we care about. And as you see, we have testability. And yeah, that's a problem, right? Because those two, which have 5 stars, reach 2 stars or even 1 star for testability. And now it comes to the trade-offs we want to make. We need to look at what we are building, and we need to look at other things. For example, cost. Do we care about cost? Do we care about something else? And maybe in the end, when you look at that, let me see, what is the best one here? Is service-based architecture, right? Which has 3 and 4, or maybe I can use the microservices as well, because like what is more important, performance or testability? And you already start seeing how having this discussion is super important. You don't start with microservices because that's what everybody's doing. There's no one universal architecture, meaning you have to choose for yourself, and you have to choose it per use case and per service and your business. Okay, so you're choosing what you need to focus on. You selected some pattern, right? And that means your work is done. No. Evolutionary is also chosen because it builds on this notion from evolutionary algorithms. And I kind of like it more because everybody's talking about AI. So let's talk about machine learning. And in machine learning, there is one option. It's called deep reinforced learning. It looks fancy because I chose a fancy picture. But the main idea is that you have an agent who does things, some action, which will change the environment. And the agent will observe it and will try to do things a little bit different, right? It will modify its behavior a little bit, like a real evolution. And how does it know if it's moving in the right direction? Well, you put something we call reward. It's a function that gives it like a score, or a game score is a good one, or reward. Like if you move in the right direction, I will reward you. If you don't, you will not be rewarded. And the system is trying to try different options and build on what it learned to achieve the highest way to get the reward. This can lead to some surprising results, because if you set this function wrong, people not. The system will optimize for it. And we are kind of thinking about the same idea. What I call reward here in evolution algorithm is called fitness function, right? It gives you how fit this algorithm is. And that's exactly what we are borrowing. And you can start writing fitness functions for your architecture. And I here have some examples how that could look like. You can write a function that checks the cyclomatic complexity. You can write a function that checks your coupling and cohesion. You can have ephemeral coupling. You can see that, how many dependencies you have from where, and you can write a function that says, I want to have a low number, like a specific number, like 5 dependencies, for example, for this module to have. And I want the cohesive, which means like inside a module, the things should be linked a lot together. I can write a function that checks performance. I can check the the response time. I can check throughput. You can say, okay, that's a metric. You are right, but metric doesn't have a threshold. That's an important difference. A function is kind of having it's a metric with a threshold. Completely different idea of how to write a fitness function was developed in Netflix when they created Chaos Monkey, which is a bot that runs in your production environment and it randomly terminates your instances. Why would you want that, right? And the answer is everybody has to count with it and they need to prepare for it. So you need to be prepared that your instance will be killed, and not by accident, but on purpose. And you are kind of forced to think about this use case. So when AWS had an outage, Netflix was one of the systems that survived because they were already prepared for this. They said, okay, robustness is super important for us, so we will have this function that will make you think of it. You can have a direction of imports, that's also important, so you know that there are no oriented cycles, for example, and you can have a correct flow. And you can even check things which you wouldn't think about, because as you remember, I said multiple dimensions. And these dimensions can also mean compliance, which means like laws. And in a way, an audit is a fitness function. It's a fitness function that you don't run automatically. It's triggered. It looks at the whole system. It's probably very expensive, but you pass it or you don't pass it, and you have to design your system so it passes the function. Here is a slide from Neil's presentation. That's one of the authors of the book, where he shows that you can combine many of these things, even like things like unit tests and, in a way, linting rules. If they support the characteristic you deem important, it can be a fitness function. That gets us to the incremental change. It's like you run this, like many of those you run with every build. Maybe you build it as an integration layer. Maybe you run it like after it's deployed, but you run it continually, and everybody has to be prepared for it. There are many tools to write fitness functions. There are even specific tools like ArcUnit, and I think it was NetArc, or not Net, but ArcUnit enables you to write these definitions that this module can only have imports from these modules. One thing I really like about this, if I go here, right? What it means that you give people, really people, I'm talking about, now I'm talking about systems. You give teams a way how to evaluate if they are moving in the right direction. You want outcomes, right? You don't tell them, use this database engine because that's how we will solve our performance. You say, our performance target is this, our robustness target is this, and our scalability target is this. And then the people who are actually experts, the real experts will find a solution. It's not your job. And I think that here comes my background where I don't have, I'm a mathematician, right? I care about solution exists, doesn't exist. But then I don't know all the databases. I don't know all the, networking. I only care that it fulfills certain requirements. And I trust the people inside the team to develop these, if they can fulfill it. I don't care how you do that. I don't care if you use document database, if you use, gRPC, whatever works for you. I don't care, as long as it fulfills the requirements we have there. And it means I don't have to be on top of all the things. I don't have to understand everything. And I don't have to be the person who understands the technology the most. And if there's a social technical shift, social meaning either people, technical meaning machines or technology, the people who are actually following that, who are part of the newsletters and everything, they know that something's happening and they can integrate it, and it's very transparent from outside. It's opaque from the outside. So that was very important. Move from solutions and implementations to outcomes, and let the team work on things. So to sum it up, evolutionary architecture means that you will first think about outcomes You can use some heuristics and some lists where people define like common characteristics, but you can define your own. Find the ones that are really important. And it's been tricky. When I did this first time, I selected like 7, but then you should really focus on like 3 maximum. Give yourself a challenge, find 3 most important things, and try to write a function for those. You will write a function, and write here is again abstract. Like it can be true function you write. It can be use a Datadog metric. You put a threshold to it, and you get a weekly newsletter sent to everybody if you don't make it. And then you can forget about these characteristics. This is the huge benefit. It is in a year when somebody comes to the system and they do a change, the function will fail because you don't meet the performance targets. You don't have to check it every time if all the change, if some change doesn't alter it, it doesn't break it. You know it's going to be validated forever. And if somebody hits it, they will come to you and you can discuss it again. And you can use your brain power for something else. That's been actually pretty great. What you can use it for is you can go to conferences. I have 2 I would like to mention. The first one is called Agile Meets Architecture. It's a conference in Berlin. I was at last year, and it happened even a year before that. And if you go to a YouTube channel, they have all the talks recorded. There's some awesome talks going much deeper in many topics, and I'm just scratched, like the social technical test systems, writing the fitness functions, and all of that. So I would recommend to look at those. What is this conference and the videos. And the other one is Web Expo 2024, which is where I will be speaking in 2 months. And this was my test run of what I want to present there. So there will be more of it and more people. And I was able to get a 20% off. And I was asked to share with you. I was looking at that and I was saying, why does it say Svarch? What is Svarch? And yeah, it's software architecture. Yeah. And also, they claim it's 20%, but I'm not sure that's true. Can somebody buy a ticket and tell me if that's correct? Okay, I see. Yeah, okay. Cool. Thank you very much, and I hope that you learned something. And if you have questions, if something is not clear, please let me know. So when I present this at Web Expo, I can make it much more clear. Jirka?
All right. We have like one question on Slido.
Oh, okay, I can. How do I? Okay. Audience Q&A. Ben says, can you give 2 examples of fitness functions you have used and describe them? What were the attributes that you need to implement your own checkers? Did you run it in CI, etc.? Sorry. Oh, okay. Cool. I would say that the performance is a very common one. So we definitely used Datadog and a threshold and an alert that gives you warning if something happens. So that would be one of them. And the other I had is we had a monolith using Yarn workspaces where you have modules, and we really wanted to have a clear distinction between the modules and not being able to call things separately. Like every module had to export one file. We had a special name for it. And we did write as custom, basically JavaScript function that just checked. I think it was based on ESLint, so it was a custom ESLint rule where you would go through it, you would look at all the imports, and this file is calling something from this namespace, and you check that they don't import anything else than the main entry point. That was one of the 2 things we did. And that was, of course, run on the CI. I think that technically you could disable it. I think that's the biggest problem with tools like this, but then people have to actively do that. And when they do that, you can come to them later and say, you should really have not disabled it. You should have come to us, which I think was also part of the error message. Yeah. Does that answer your question, Ben? Okay. Okay. Next one I have here. What is your approach to introduce architecture changes efficiently in terms of efforts required for further modification of production goes tests, CI/CD? I'm not sure I completely understand architectural changes. I mean, architecture changes, that's very broad topic. I think that my approach has always been to look at the subdomains. Like, I really like when you have an isolated. I mean, I'm a big fan of domain-driven design, right? So if you have a bounded context, something that holds together, that module I was talking about with high cohesion. I think that you can do two things, right? You either change on the level of the module, so you gradually change that module to a new, characteristic or something inside it. For example, if I change persistence layer, it should be an opaque change from the outside. And then again, you can write a function which would check for the API contracts that you don't break them. And if you don't break the contracts, you can do whatever you do inside the function. So that would be, I would say, the small change inside a module. If you do things outside of the module, it's tricky. There are many options to that. I mean, ideally, you can rewrite the service from scratch as a new one and gradually shift or like move to it. And either voluntarily, which is some approach many people do, is you just say, okay, there's a new service. I think that there was an example. What was the example? You have a rating with stars, 1 to 5 stars, and the service provides this rating, and you enable half-star rating, right? And you don't want to make a breaking change, so you create a new service that allows half-star rating. And as teams gradually migrate to the new service, the old one is still working and maybe translating things in between. And at one point, you will see that nobody's actually using the old service, so you delete it. That's a little bit idealistic, I agree, but I think that gives you the idea that you can like move on the higher, on a larger scope than just inside the service, and you can really replace services one by one. Yeah, okay. I'm thinking if there's something else I want to say about it. Thank you. I guess I don't. I know you say it's impossible to make predictions, but how do you think the software design will look like in the 2030 web apps, for example? Okay, is this being recorded? I'm not making predictions on the record. Okay, I mean that's impossible. I think that we will see more variety of how things are done. And for example, I've been a big, like huge fan of React and the way how it creates, how web apps are created using React. But then it's because it was the apps I was writing were kind of suited for React. And there's, for example, approaches like HTMX, and I know that many people don't like it, but for me, that makes a complete sense to have something that actually uses RESTful API, like RESTful interfaces, and uses HTML, HTTP to its fullest potential. And it actually means that you can drive the application from the backend, something we haven't seen in the past few years. So I can imagine that you will have more of those opinionated pieces, and you can select the one that fits your characteristics, your needs for your system. And I think that the system will, like the landscape will be more fractured, if you will. Web apps. I mean, you mean web apps like for mobile phones? Friggy, where are you? Friggy? I see. Okay. That's Zoom. Yeah, I think it's going to be more fractured. And web apps, I don't, I don't think that web apps are the future, though. And that's because platforms like Apple, they care about security and they care about things like trustworthiness. And I think that with web apps, you give too much power to everybody and you don't have any control. So yeah, I don't think that people will use that. Yarda, so is architecture still necessary in Agile? Okay, I failed to explain that. I should have said that. That's a good point. You always have architecture. You always design a system in the worst case, you don't do it explicitly, you just implicitly select something. So you always do architecture. It's not optional. You always have it. What I think is still necessary is to think about it and to cautiously define what pieces of architecture you really want to even look at, and which pieces you want to implicitly ignore. And the last question, do you know some sources which predict some upcoming architecture issues? For example, crypto crisis due to quantum computers, maybe something else you see, some general challenges? No, that's way too high level for me. I saw some things about quantum computers. I don't, like people say, yeah, maybe one day somebody will come and say, it's done. We cracked all the algorithms, whatever. Maybe somebody else says, we achieved the universal AI and you are fired. I mean, that all can happen, but I can't predict that. Like, I don't really have that. In a way, I think that many of these changes are being overvalued, or like people fear them a little bit too much. I think the changes are more like gradual. Sure, there's sometimes a big shift, for a better word, but I don't. Yeah, no, I can't predict them. Sorry, if you wanted to sell that information, I don't have it. Cool. Thank you very much. I will be here. I mean, here in this office, probably somewhere there, more like. So please come to me, talk to me, tell me. I especially care, and that's why I want to stress it out. Tell me where this didn't make sense, because I think there will be a lot of pieces. It's sometimes very difficult to carry, something that you understand to somebody who hears it for the first time. Right. Thank you.